Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how new observations of the Helix Nebula are revealing what happens to material expelled by a dying star. So let's get started. What happens to the material a star releases near the end of its life? We often say that stars return material to space where it can eventually become part of new stars and planets. But there is a missing step in that story. How does recognizable stellar debris actually become part of the diffuse gas between the stars? New observations of the nearby Helix Nebula are allowing astronomers to watch evidence of that transition in remarkable detail. The Helix Nebula is a planetary nebula located about 650 light-years from Earth. Its familiar bright structure consists of material expelled during the late stages of a star's life, surrounding the white dwarf left behind at its center. Eventually, some of that expelled material will become part of the interstellar medium, the thin gas and dust that exist between the stars. But observing that transition is difficult. The material becomes increasingly faint as it expands away from the central star. And that means some of the most interesting evidence may lie well beyond the bright nebula we can normally see. To detect it, astronomers needed an instrument designed specifically to find extremely faint, diffuse gas. That instrument is called MOTHRA, the Modular Optical Telephoto Hyperspectral Robotic Array. MOTHRA combines observations from large numbers of telephoto lenses to detect extremely faint ionized gas. And interestingly, the researchers were using the Helix Nebula as a calibration target. They chose it because it was already one of the best studied planetary nebulae in the sky. But when they examined the faint outer regions, they found something unexpected. Far beyond the familiar bright nebula, the observations revealed 22 complete or partial bow-shaped structures concentrated on the eastern side. A bow shock forms when an object moves through surrounding material, somewhat like the curved wave that develops in front of a boat moving through the water. Here, the glowing arcs trace places where clumps of stellar debris are moving through the thin gas between the stars. But simply finding bow shocks was not the most interesting part. Their appearance changes systematically with the distance from the center of the helix. Those closer to the central regions tend to be larger, thinner, and more sharply defined. Farther away, they become smaller, fuzzier, and increasingly fragmented. That progression gave astronomers an important clue. The researchers interpret it as evidence that the clumps themselves are gradually being eroded as they travel through interstellar gas. The interaction strips material away. The fragment becomes less coherent, and eventually its material becomes mixed into the surrounding interstellar medium. The researchers estimate that once one of these fragments is exposed to the surrounding gas, it may remain coherent for only about 10,000 years before much of it is shredded and dispersed. That gives astronomers something they have rarely been able to observe directly: the transition between stellar debris and interstellar material. And that transition is fundamental to the chemical evolution of galaxies. Material produced and expelled by one generation of stars can enter the interstellar medium, where some of it may eventually participate in the formation of later generations of stars and planetary systems. Even our own sun will eventually return material to the galaxy through its late stages of evolution. There is another lesson in this discovery. The Helix Nebula is not a newly discovered object. Astronomers have studied it for generations. What changed was our ability to detect extremely faint material surrounding it. And those faint structures revealed a process that had been difficult to observe. Stellar material gradually losing its identity and becoming part of the space between the stars. A star may reach the end of its life, but its material continues through the galaxy. So that concludes our discussion on the Helix Nebula reveals how stars recycle their material. We'll be back again next time for another new discovery in astronomy. So until then, have a great day, everyone, and I will see you in class.